perfect can of worms to open because it's the rest of the course's can of worms.
Can we look at everybody's cumulative data?
Yes, absolutely. We'll throw that in next if you don't mind. I want to compare you guys first, only because this is the one data set you're probably going to get in a study. Lauren's saying, can we also check everybody else's data? Of course we can. I want to do that because it has an effect on the inference. But one thing at a time, if you don't mind, because I want to compare and contrast them. What do you think, based just on our curve versus the theoretical curve? Are we doing better than guessing?
Yes.
It looks, I hear the word we're skewed, I hear a vote for yes.
But outliers will happen, so we can't.
But outliers can pull. I love what I just heard all three of those. It looks like it's skewed. And skewed, I know sometimes we get worried about the word skewed. Skewed from guessing. It looks like our curve is shaped-ish like the bell curve, but it's over here. It's almost like we have a different bell curve. It's more to the right, which might imply that we're doing better than guessing. Good, good. But Lauren has a concern, which I think is a valid one. Maybe we have some outliers we need to contend with. Let's take a look, shall we? This is where I love Kate's idea from before about slapping a box plot up there as well. Let's do it. Plot 3. Mine's already set up to do a modified box plot. Yay us. L1, L3. No, you're right, L1, L2. You're right, Kate, L1, L2. You're 100% correct. L1, L2, because L3 is the theoretical. We don't have any. Good, but did you hear what Lauren just said? She said check for outliers because outliers can pull the average up, and that would make our data look more impressive than it actually was. In the case of Angie's 10, for example. If that were an outlier, it's kind of like Jason in my abstract algebra class sitting in the back of the room calling out answers. If I treat that as a normal data point, I get a skewed version of what the entire class looks like, don't I? Remember, I told that story about an hour ago about the autistic savant kid in my abstract algebra class that would just call the answers out to my prof, complete my prof sentences. And the prof assumes, y'all know what's going on. He actually told me that in office hours. Well, Jason's always answering questions. Yes, n=1. Jason is always answering questions. We as a class are confused as hell. But if we look at Angie's 10 and go, boom, that's good. That's like looking at Jared and saying, everybody going in Subway, you'll lose 30 pounds. Doesn't make any sense because it's an outlier. Potentially, so you check to see if it's an outlier. As it turns out, it's not an outlier, it's just the biggest data point. And we can check that by doing a quick little graph. And there it is. There it is, no outliers. By the IQR method, I would almost guarantee no outliers by standard deviation as well. So everything's golden as far as data, it just looks like it's skewed. It just...
Everybody's
Hold, we're not done with ours yet. Now, you Lauren's like, hurry it up, damn it! Why aren't we done, friends? I'm going to turn that box plot back off, because now that we've checked for the outliers, we don't need it. Go ahead, D. What's your question?
Is that the beginning of the bar is 10, or the middle of the bar is 10?
The beginning of which? Oh, so here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each bin is its own number of correctness.
Right, but I mean, is it the left-hand side is 10?
No, this is 0.
Well, when you had the box plot up there, the one...
Yeah.
Oh, that box plot was your data set. The left bar was your smallest data point. The right bar was your largest data
I
point.
think what she's asking is on the right bar at the very end, cut off like.
Let me put it back on. Sorry.
You'll see.
Yeah. No, this is good.
Our graph is also, you see where it's.
Oh, right here?
Yeah, right.
So, is that... Thank you. I'm sorry. Thank you, JC.
But it would
Yes.
show up with a little square key.
Okay, that's 10. And the
Because
reason
the
is...
other, our graph is 11.
Exactly. This data point right here is technically 11 because the TI thinks it has to graph continuously. So your maximum 10 is right here, but you can view this whole bar as 10. Yes, I see. Thank you, JC, for pointing that out. Yeah, I was totally misreading that. Dina. Cool so far? Now, but Lauren's getting impatient. And she should be because, wait a minute, all we're doing right now is we're hypothesizing that we're doing better than guessing. So if we were guessing, we'd land there on average, wouldn't we? We'd land there on average. Now, I don't think we landed there on average. There are no outliers. There are no outliers, so we're golden there.
We're slightly above.
Where is our
I
average?
think it was at 6.
Maybe a vote for 6. If I was to ask you, based on your data right here, on average, how many times do you guys get this correct out of 10? At 95% confidence.
Oh, that's cute.
What
That's
would,
good.
I would have to do that, right? Because isn't there sampling error built into your guys' results? Isn't there sampling error built into your guys' results? You guys are a sample. I can't look at this graph as a population, it's just a sample that we drew today.
So we'd have to do a T.
We have to construct a t-interval, don't we? We have to construct a t-interval around this and have the uncertainty measured. Let's do it. Let's do it. Yes, we have to, we have to. There's definitely